So, ladies and gentlemen, welcome to this other session of Kurgatering Finance and Accountancy Tutorials. Today, we are going to look at quantitative analysis or quantitative techniques, and to be specific, linear programming topic. So, this quantitative analysis, or techniques. And to be specific, we are going to look at linear programming. So, ladies and gentlemen, linear programming is, or rather, linear programming problems. So, these where the managers normally, in most cases, use it in making critical decisions. Given that in each and every organization we have limited resources, in terms of raw materials, we have finances, we have the human resources, and so many other resources in an organization. So in that case, the linear programming is there so that to help the manager in making those decisions, so as to distribute the limited resources for maximization of profits, and in most cases to minimize costs. So before we continue, ladies and gentlemen, if you are not subscribed to the channel, please do so, and if you are returning subscribers, I welcome you so much. So ladies and gentlemen, in solving the linear programming problems, we have those special types of linear programming that are used to, or rather that are applied by the manager in making those critical decisions of distributing the limited resources. And the special types of linear programming, number one is transportation problem. And number two, we have the assignment problem. So in this case, we have some others, but in this case I'm going to major on the two, because these ones are the ones that are majorly examined in those professional examinations. So today we are going to start at transportation problems, where I'll be taking you through the same, and then you look at KASNEB examined question that was examined in some years back, so that we get to what we are talking about here. And then assignment will come in subsequent sessions altogether. So without much ado, let's start with transportation problem. Okay, so transportation problem. Here, the manager is trying to, as much as possible, minimize what is known as transportation cost. That is the cost of transporting the goods from one source to one destination. So in that case, we are going to look at an example later on, but before we look at an example, it's good that we explain what this transportation problem is all about. So ladies and gentlemen, transportation, as we all know, is making sure that we relocate the goods from one place to the other. That is transportation. But in quantitative techniques, then we are going to look at it in a different way, this way, that here we are trying to transport an item or some goods from several or select sources to select destinations, yes, with an attempt of, it's so much looking at minimization of the transportation cost. So you see here, ladies and gentlemen, that we have sources and we have destinations. So we are trying to transport these goods from these sources to their destinations. So the sources, ladies and gentlemen, can be the manufacturing companies. The manufacturing can be the manufacturing companies, can be warehouses, can be warehouses. So that is the source where the goods are coming from. The goods are coming from. So you will find that from these sources, the warehouse and the manufacturing. So here we are going to find the supply, because they are the ones that supply these goods and services. And then the destinations are where these goods and services are landing. It's kind of, you're selling those goods to that place, but trying as much as possible to reduce or minimize transportation costs. So the destinations can be shops, yes, the manufacturing company selling to shops, or transporting the same to the shops, sorry, or to the households, or the customers. So we talk of the shops and households, all of them, we can sum them up together and say these are our customers. So here under transportation, we are trying to transport the goods and services from the sources being maybe manufacturing and warehouses. These are just examples I'm giving, to the select destinations, which can be shops, households, and customers. So in here, there is what is known as transportation costs. Yes, so the cost here can be maybe 1,000,000 shillings to transport maybe one lorry of a certain product to destinations, but there is an alternative way that maybe can be used to reduce this cost better. So in that case, that is what we are going to look at under transportation problem. Okay, so ladies and gentlemen, having understood what transportation problem is all about, then it is important for us again to look at the assumptions of the transportation problems. So there are two assumptions on the transportation. So assumptions of transportation problems. Number one is that it assumes that we are dealing with a homogeneous commodity. Yes, homogeneous commodity. Homogeneous here means one, right? So it means that we are dealing with one type of a commodity at a go. So this is one of the most important assumption of transportation problem. It assumes that we are only dealing with one type of a commodity. So if it's rice that we are transporting from one place to the other, that is only rice that we are talking about. If it's sugar, then it's only sugar that we are moving from one source to a given destination. So that is all about homogeneous commodity is all about. And then number two, it also assumes that the total supply is equal to the total demand. Yes, so this one is total supply is equal to total demand. So that is a very, very, very important assumption of a transportation problem that you should be having in your fingertips, that you're dealing with only one commodity type and that the total supply must be equal to the total demand. So ladies and gentlemen, we are going to use this assumption in a question that was examined before by KASNEB. Having known or having understood these assumptions of transportation problem, now next is for us to understand the methods of solving the transportation problem. Okay? Methods of solving transportation problem. Ladies and gentlemen, here we have three methods of solving transportation problems, and the methods are number one, the northwest corner rule. Northwest corner rule. Then the second one, B, is the Vogel's approximation Vogel's approximation method. And then number C is the least cost method. So these are the methods, or rather these are the methods that are used to solve the transportation problems. So from the term northwest, okay, we have our compass here. This is the north, this is south, this is east, and this is west. So we are going to use this concept, the geography concept, or the compass concept, for us to understand what the northwest means. So it is the north and then the west. So we are talking about this region. Yes, the northwest corner rule. So others will follow. So we are going to take a question that will make us understand, a question that will cover all of these methods, right? So that we get to understand how to solve the transportation problem with a lot of ease. I will make it so simple, yes, and this one will have enhanced your understanding of the same. So without a much ado, I want us to look at that question so that we can handle it together. Okay, the question was on June 2011, question 3C. So that was on quantitative analysis or quantitative techniques. So this is June KASNEB. June 2011, question 3C. So that is the question that we are looking at today. So the question reads that Great Handles Limited has 3 warehouses. We have warehouse 1, warehouse 2, and warehouse 3. So the table below shows the inventories of rice in 3 warehouses. We have warehouse 1, we have inventory of rice being 260, warehouse 2 168, and warehouse 3 172. So the company is required to supply 3 of its customers, that is customer 1, 2, and customer 3 with rice. So the requirements of customers are as follows. Customer 1 is 280 bags of rice, customer 2 120, and customer 3 200 bags of rice. So the data below shows the cost of transporting 1 bag of rice from warehouse to the customers, right? So given this kind of a question, ladies and gentlemen, then you need to make sure that you understand all these figures that you are given. Make sure that you understand what is a supply in what you've been given here and what was the demand. So from my own understanding, how I have analyzed this question is that we have the sources being warehouse 1, warehouse 2, and warehouse 3, and the destinations being customer 1, customer 2, and customer 3. And then the cost of transporting 1 bag of rice from warehouse 1 maybe to customer 1 was 100. And then from warehouse 1 to customer 2 is 80, customer 2 is 80, sorry. And then from warehouse 1 to customer 3 is 120. And then from warehouse 1 to customer 1 is 140, warehouse 2 to customer 2 is 80, and warehouse 2 to customer 3 is 140. Warehouse 3 to customer 1 is 160, and then warehouse 3 to customer 2 is 120, warehouse 3 to customer 3 is 140, right? So here we have from the warehouses, these are the sources, so this is where we get our supply, and then the customers now creates the demand, right? So here we have supply and demand, and then the cost per unit is given in that matrix. You are going to generate a matrix there. So let's look if the assumptions of transportations have been obeyed in this question. So one of the assumptions of transportation problem is that we must have a homogeneous commodity, that is one type of a commodity. So here we are dealing with rice only, we don't have any other goods. So and then another assumption of transportation problem is that the total supply should be equivalent to the total demand. So you are going to look at that. So here we have supply from the warehouses, and then we have demand from the customers. So you are going to add the demand, the demand of all the customers, and then we equate to the supply that is available from these warehouses, right? So that we see if really the assumptions have been obeyed. So let me just write these matrices down. So we have the supply, we have warehouse 1, the sources, we can say the sources. We have warehouse 1, warehouse 2, we have warehouse 1, warehouse 2, and warehouse 3. So here we have inventory of rice. We have rice in bags. Yes, so we have a total of 260 here, 168 this other side, and 172 on that other side. So these are the sources, and we can call them supply. These as per my own analysis, right? And then you have the demand, where we have the destinations. Here we can call it demand, right? So we have customer 1, we have our customer, we have customer 1, customer 2, and customer 3, right? And then you have the rice again in bags. The question is talking about bags. We have one customer is 280, then the other one is 120, then you have 200. And then you now have the cost. Having the supply and demand, we are going to add them to check if the assumption of total supply is total demand, right? So then we have the transportation costs. The transportation cost, so I can see from warehouse 1, we have warehouse 2 and warehouse 3, then you have customer 1, customer 2, and customer 3. So the cost of transporting from warehouse 1, transporting one bag from warehouse 1 to customer 1 is 100, and then 80 to customer 2, and then 120 to customer 3, then 140 customer 1 for warehouse 2, and then 80 and 140. Then you have 160, 120, and 140, right? So these are the costs of transporting one bag from the respective warehouses to the select customers or the select destinations. So here we are required by the question, we are required to find the minimum total transportation costs, using number 1, the northwest corner rule, right? And then Vogel's approximation method, which is also known as VAM, and then the least cost method. Number 1, we are going to start with the northwest corner rule. So our solution, let's start with the first one, the northwest corner rule, what is known as northwest corner rule. This is what we are going to do right now. Okay, so I'm going to create a matrix. I'm going to create a matrix given this information, and then I try equating the demand and the supply just in the same matrix. Are we together? So we are going to pick what we have here, the transportation cost, and then we input the supply and demand, and this is how I'm going to do it. So we have warehouse 1, warehouse, we have warehouse 1, warehouse 2, warehouse 3, right? So let me give it some space, warehouse 2 and warehouse 3. So we have customer 1, we have customer 1, customer 2 and customer 3. Yes. Customer 1, customer 2, customer 2, customer 3. So we have 100, 100, then you have 140, then you have 160. I'm getting the information from here. Then you have 80, then we have 80 again, 80, then you have 120, then you have 120 here, we have 140, then you have 140, right? So this is the transportation costing. So we are going to look at the demand. The demand here, what was the demand? The demand is here from the customers. We had the demand of 280, and then a demand of 120, then you have the demand of 200. What about the supply? Supply, you write it here, the supply, we have the supply from warehouse 1 is 260, write 260 here, and then we have 168 and then 172. So the assumptions, so let me just draw. So ladies and gentlemen, from the assumptions of transportation problems, we said number 1 is that we are dealing with one type of a commodity, and in this case we are dealing with rice. So we are done with the first assumption. Assumption number 2 is that total demand must be equivalent to the total supply. So when you add the total demand, 280 plus 120, with these 400 plus 200 is 600, must be equivalent to the total supply of 260, 168 and 172. So when you add 260 plus 168 plus 172, we are getting 600, right? So, and then the total demand is also 600. So the second, so you can see that we are okay as far as the assumptions are concerned. The total demand is equivalent to the total supply. So what we are supposed to do next is that we are going to solve this problem now that I've brought about this table, the matrix, using the northwest corner rule, right? Northwest corner rule. Now there are some steps that must be followed for you to be able to handle such kind of a question, or rather to solve using the northwest corner rule. And number 1 is that you allocate as much as possible, right? You allocate as much as possible to the northwest corner of this table. That's why I was just saying that the compass issue, the northwest, we are going to deal with this part. So when you put your compass here, the north is on this side and then west is this side. So you allocate as much as possible to the lowest cost in the northwest of the same, right? So like in this table of ours, here we have north being here, northwest being this side. So the northwest is around these 100 and 140, right? So but the least cost is 100. So we are going to allocate as much as possible to this cost, right? Irrespective of whether it's supply or a demand, but you're going to allocate as much as possible here, because that is where the Northwest is. Are we together? So let's look at it. We say the total demand must be equivalent to the total supply. So here we have a supply of 260, but we are going to allocate the 100 because this is what we have identified, as far as the northwest corner. Northwest corner. This is the lowest, 100, right? So this is 260, and then the corresponding demand. Are you together? So this is customer 1, warehouse 1, customer 1, and then this customer 1, demand for customer 1 is 280, but we are going to allocate as much as possible to this cost, the transportation cost, where we are going to look at the supply 260 and then 280 the demand. So we cannot allocate beyond what is demanded by customer 1. I'm going to allocate the whole of 260 here. Why? Because the demand is higher. The demand for customer 1 is high. Are you together? It's higher than even the supply that warehouse 1 can provide at that point. So given that we have identified this one as the lowest and following the northwest corner, we are going to allocate the full of 260 to this demand of customer 1. So this is how we are going to do it. You just draw, let me use a different pen. So this is how to do it. So you just draw as such, and then we allocate the whole 260. I'm allocating 260 because the demand is higher. The demand is higher. So since I've allocated, I want you to look at this very keenly. I've allocated here. So that means this row, or this row, I no longer require this row. Are you together? So since I no longer need it, I'll just draw as such. I'll just cross it off. I just cross it as such, and then since the supply is full, then I will say minus 260. We are remaining with 0. And then here we are going to say minus 260, so we are still remaining with 20. Are you together? So since we still have, customer 1 still requires 20 in either warehouses, irrespective. Are we together? So we have cancelled off that row. That means we no longer require the row anymore. Are we together? That is number 1. That is what we've done. And then step number 2 is that still we are going to look at the northwest corner using the same compass from what is remaining here, and then we allocate as much as possible to the lowest cost in what you've identified in the north corner rule. So here, when you place our compass here, somewhere here, are we together? This is the north and the west is here, meaning this cell is the one that is coming next in the northwest corner, isn't it? In the northwest corner. So here, this is customer 1, warehouse 2 is 140. But this warehouse 2, we have a supply of 168, right? But what is remaining for customer 1 is only 20. Customer 1 demands 20 only, requires 20 bags of rice, isn't it? So since it's only 20, we are not going to write 168 here. Okay, we are going to allocate as much as possible here because it's the lowest cost, isn't it? Because it's the lowest cost in the northwest. It's the lowest one, but we are not going to allocate full 160 because it's only 20 that the customer one requires, right? So we are going to allocate 20 so that we do away with this 20 here. So you'll say minus 20, so we are remaining with 0. So that means this column is done. Why? Because this is 0, right? And then this column, we are just going to reduce 20, and then you remain with 148. Are we together? 148. But we are not going to cancel off this row because we still have 80 and 40. still in warehouse 1 as the transportation cost. I want to believe you are getting that. And then we move on next. Step number 3 is that we are going to repeat what we've done. You just prove again, check the northwest corner, you just place your compass here, and then check the northwest. So our northwest is somewhere here. And then we allocate as much as possible to this cost. Are we together? Subject to the supply and demand. So you can see this is warehouse 1, right? Warehouse 2, customer 2. Are you seeing that? Warehouse 2, customer 2. So here we have 148, right? 148 available for supply in warehouse 1, and this customer 2 requires only 120. So that means we are going to allocate what this customer wants. We cannot allocate the full of 148 and the demand is 120. So we are going to take the list. So we are going to take 120. So that means we are going to reduce 120 here so that we remain with 0. And again we reduce 120 here so that we remain with 28. Remain with 28. So that means since this column now is 0, so we are going to cancel off as such. That one is done. So that means we are only remaining with these two, the warehouse 2, column customer 3, warehouse 3, then customer 3 also. Still place the compass northwest. So this one is the one that is taking next. So we are going to allocate as much as possible, but with keen interest with checking the supply and demand. So we have the supply of 28 and then demand of 200. So we are not going to place 200 here because we will be violating that rule now that we only have 128 to supply. So we're just going to write 28 that we still have to supply from warehouse 2. We allocate it there, and then we say minus 28 here, we get 0. Are you together? And then here you say minus 28, you remain with around 172, right? You can check from your calculator. So that means this column is now 0, not column, the row. So this row is 0. Now you cancel off. Are you together? You cancel off as such. But you're not going to cancel this one because you still have to allocate. So since it is the only one that is remaining, now we allocate the full 172 here, so that we remain with 72 is equal to 0. And then you say minus 172 is equal to 0. So having that in mind, now you cross off. Now, ladies and gentlemen, that is how to do it. That is how to do the northwest corner rule, or rather solving the transportation problem using the northwest corner rule. And this was a KASNEB examined question. So our next task that you are going to do is that you are going to find the total transportation cost. Yes, the total transportation cost, and this cost is the one that has been minimized. Are we together? So we are going to find the total transportation cost. Total transportation cost. So ladies and gentlemen, again, this is how to do the total transportation cost. Look here. I want you to be very keen that you have the ones that we have allocated is what you are going to multiply. Are we together? So we are going to multiply the number of bags with the cost that in that portion. So like in this case, we have warehouse 1, customer 1. So warehouse 1, customer 1 is equivalent to, we have 260 bags. You multiply by 100 transportation cost per 1 bag of rice. You get its answer, right? And then we have next that you have allocated is warehouse 2 for customer 1. Warehouse 2 for customer 1 is equivalent to 120 times 140. Next is warehouse to customer 2. Warehouse to customer 2 is equivalent to 120 times 80. 120 times 80, get the answer. Then you have warehouse to customer 3. Warehouse to customer 3. Warehouse to customer 3 is 28 times 140. Then you are remaining with warehouse 3 customer 3, which is 172. You multiply by 140, you get the answer. 260 times 100 is 2600. That is 26,000 is 2,800. And then you have 120 times 80 is 9,600, if I'm not wrong. Then 28 times 140 is around 3920 is 24,080, right? So we are going to add all of them. We are getting 66,400 Kenya shillings. So that is the total cost. That is the total transportation cost. So that is the total transportation cost of transporting the rice from the destination warehouse to the respective, from the sources, the warehouses, to the destinations, the customers. So ladies and gentlemen, if you have a question pertaining what we've done today, make sure that you contact me via the contact details that I have provided in this channel right together. So I want to believe that I have done justice to transportation problem solving using the Northwest Corner Rule. And if you are not subscribed to this channel, please do so, and also recommend the channel to your friends so that they can know that you also have a channel that we can learn for free. So thank you so much. May God bless you, and see you in the next session, where we'll be looking at the Vogel's approximation method of solving the transportation problems. See you. Goodbye for now.